Hey everybody, this is the distance versus displacement video lesson. The learning target for this lesson is I am learning to distinguish between distance and displacement. The success criteria for this lesson are I can define distance, I can define displacement, and I can recognize the equation for displacement. Alright, so let's start talking first about distance. So distance is defined in physics as how much ground an object has covered. It's magnitude only, so no direction, so it's a scalar quantity. It can be a curved line, it can even go over itself. So distance is kind of how we think about how much distance we've covered, how far we've gone in our everyday usage of the word distance. So as an example of distance, we could think about if you were moving around between classes. So let's say you went from my class down here, Mr. Voss's class, and you wanted to go to Ms. Campos's class for Spanish after my class. So you left my class, you walked through the halls of the science department, and you left the science building and you went through the courtyard, through the main building. You went all the way through the main building over to Ms. Campos's class way over here. And then after class, you got out and you had to go all the way back to the science building to go to biology in Mr. Babbage's room. So you walked all the way back through the main building, you walked all the way back through the hall, you came back through here, you went back through the courtyard, back down through the science building, and then ended up in Mr. Babbage's room. So all that way that you traveled, that would be considered the distance. Notice that you traveled over some of the same path, and even though you traveled over the same path, that is all counted as distance. So what about displacement? So displacement, on the other hand, is an object's overall change of position. So how far something is from where it started. So displacement is a vector, meaning that we need to know both the magnitude and direction. So both of those quantities are important when we're talking about displacement. And displacement is always a straight line. So we're not talking about any curved lines or anything like that. All we're talking about is the straight line distance from where you started to where you ended. And we want to know exactly the direction that you went in from where you started to where you finished. So let's look at the equation for displacement. So displacement, we have delta x, and that is equal to your final position. So x here without a subscript is your final position, and x naught, so that little subscript of a 0 there means x naught, that's your initial position. Okay, so let's look at displacement. So with all of that distance that you traveled to go to Ms. Campos's class and then you came back, the displacement, really all we care about is that you left my room and went to Mr. Babbage's room. So that's the displacement. And because displacement cares about the direction, we need to draw a little arrow here. So you went from my room to Mr. Babbage's room, and that is the direction that you traveled in, so that is the direction of the displacement. Okay, so let's look at a couple of examples of distance and displacement. So let's say that we are going to start at this point at the x, and we're going to end at the O. So for distance, let's say we take this path here and go like that. So for distance, that whole path is included in the distance measurement. So we would measure this whole path. The entire path is included in the distance measurement. On the other hand, for displacement, we'll try and draw that same path over here for displacement. Similar path. For displacement, all we really want to know is how far you went and in what direction. So for displacement, we just want to know the straight line path, where you started, where you ended up, and what direction you went in. So for another example of distance, let's imagine that you're running on a track. So maybe you run track and field, maybe you play football or soccer, and you want to, and you're doing some exercise on the track, you're running laps. So let's say that you start here and you end here. Okay, so for distance, the number of laps that you make, let's say you make 2 laps. So you go around, that's 1, you go around, that's 2. That would be 800 meters. That's your distance. For displacement, on the other hand, start here, so you start here and you end here. Your displacement, on the other hand, because you start and stop in the same place, your displacement would be 0 meters. So hopefully through these 2 examples, you can tell the difference between, you start to see the difference between distance and displacement. So remember that that for distance, you're talking about the entire way that you go. You can cross over the path, you can go backwards and forwards. With displacement, you really only want to know from where you started to where you ended and the direction that you went in. Okay, so let's talk about what we've learned in this video. So we learned that distance is a scalar quantity, and it talks about how much ground an object is covered. Displacement, on the other hand, is a vector quantity, which is the overall change in position. So how far from where we started. And the equation for displacement equals final position minus initial position. All right, everybody, thanks a lot.